Before we go on our tour of the Boulder Creek CZO, let's talk about the interactions that we're studying that drive our research. In a nutshell, we're trying to understand how rock breaks down into soil. This is a fundamental process that shapes the lay of the land, and understanding this helps us understand how a watershed works. There are many interlaced systems that are involved in this. For instance, the water cycle, great glacial episodes, dramatic fires and floods, and rivers that are carving down into rock, as well as many very much less dramatic but very persistent processes we're interested in, like trees that are growing, prying rocks, falling over, ice that will form and crack rocks and then melt and go away. Microbes can get in the act as well. They're breaking down rocks, releasing nutrients and cycling elements. All of these processes work together. In fact, if you think of the landscape as a giant painting, we're interested in how everything from the broad brushstrokes to the tiniest details, the small strokes and the textures together work to make the statement of the painting. So we want to understand how all these different processes, the dramatic and the persistent processes, work in concert to generate the way the landscape looks and how it operates. In fact, in this watershed, we've got summits that are craggy, we have plains that have flat, broad terraces. Both of these environments are generated at the same time. We want to understand the connections between all of those parts of the landscape. Out of this rich mix of processes, we're trying to identify which ones are the ones that matter the most, which ones really stand out in shaping the fate of the landscape. A fascinating piece of this for me is actually seeing how different regions are connected in landscapes. What happens in one place affects what happens elsewhere. For instance, here in the Front Range, the rivers on the plains are downcutting and leaving behind terraces when there's a change in the sediment and water delivered from the headwaters, from the mountains. So that's a teleconnection in space that happens here. There are also connections that happen in time. The legacy of past climates will influence modern processes. For instance, the headwaters now have large regions that are bare rock, which is a legacy of the glaciers that were there in the past. The beauty of a project of this scope is that we get to bring together research from many different related fields. We welcome other scientists coming here with their tools and their questions and bringing them to this place where they can benefit from our data and monitoring, and we can benefit from their insight. A recent example of interdisciplinary work is how seismic surveys allowed us to glimpse through the weathered rock and down into the deep, fresh bedrock underneath. By sending sound waves into the ground, we can see under the soil and into this weathered rock layer that takes hundreds of thousands of years to form here. This allows us precious access to that deep time perspective that we're so interested in. It's really a frontier, and this getting to see into the subsurface is like having a telescope that lets us look back in time.